I'm very happy to see that you are present to this particular session. Let's give 2 minutes for the latecomer to join us so that we can start. Okay, so while waiting for the others to connect, let's quickly recall what we did last time and what we are going to do today. So last time we had a hands-on practical session. We used MATLAB. We used MATLAB to perform the least square approximation of to fit the data to a straight. No, it was not a straight line, but it was a quadratic polynomial. So for that purpose, what we did, we constructed our linear system whose coefficient matrix was a rectangular, not a square matrix. And in MATLAB, we use a backslash. And I told you that that backslash, behind the backslash, there is an algorithm. That algorithm will first assess the shape, the nature of the coefficient matrix A, and will determine the optimal method. So if you realize, if he checks and finds that, okay, this matrix is not square, he understands automatically that now here we are dealing with a least square problem. So he will go directly and use the appropriate algorithm to solve the least square problem and return the coefficient that we are looking for. That is the solution to our linear system. So that's what the backslash does. So backslash is not only Gauss elimination. It is Gauss elimination. It's also Cholesky. Cholesky is Gauss elimination when the matrix is symmetric. When it is symmetric, your coefficient matrix can be factored as, instead of LU, it will be L. U will be equal to T on L transpose. Right? So that's the difference. Let me quickly summarize it. I think we already started. Let me quickly summarize it here for your information. Okay, so what I was saying, is that if you have a set of data points, we have x here, which is a vector, and y, another vector. Obviously, where x x1 up to, let's say, xn. Similarly, y, y1 yn. So this is a set of data points which correspond to the table. That is, from the table you extract. If you are given a table, you can extract the x component, the y component, and put it there, and put them there in x and y. Okay, now we want to fit a polynomial to this, right? So we fit a polynomial to this one, that this is the least square. We fit to this set of data points. So we want to fit or we fit, we want to fit or we fit, same thing. So we want to fit this polynomial Pn. Okay, if I take the P2x, for instance, yeah, this is second degree polynomial here. Okay, I will call this m, so that the m and the n for the degree will not seem to be the same. They are different. Because if I put n here and write here that n is 2, it will really lead to confusion. So this is the degree of the polynomial. So that's the degree 2. So we want to fit this to that. Remember, we obtain the coefficient A1, A0, A1, A2 are determined by solving a normal equation, right? Now we saw that with MATLAB, what we do, we construct our system. Let me. We will construct our system and we will solve for the unknown, and the unknown will give us a coefficient A0, A1, A2. So here we have 3. 3 here, you can see 3, 0, 0, 1, 2, 3. For this one, if we fit a second order polynomial, then we have a total of 3 coefficients, which is n plus 1. It's n plus 1. We fit to this one. You will see that if we have m and we fit that into this one, you see that whether m is less or greater than, there will be more or less equation compared to the number of unknown, right? To have a square matrix, this m should be equal to n plus 1. Then the number of equations will be equal to the number of known. But generally, m and n are different. That's why we obtain a rectangular matrix instead of a square matrix, right? So we saw how to solve this. So let me realize that it did not open that one. Let me quickly go to that one, and because what we are going to do now is to do this to solve a similar problem using Python, because very few of you will be able to get MATLAB installed, whereas Python is open source, it's free. You can download it from the internet. I think last year, no, what am I saying? During the first semester, I think we downloaded, yes, we downloaded Anaconda. If you remember Anaconda. Anaconda comes with, it's a package that comes with Python, and it comes with Python, it comes with Spider, which is an IDE, that is the environment where you have how do you call this? You have a GUI, which is a graphical user interface, but it has something like words, like words. It allows you to type, to type. You call it, how do you call this? Spider, you say yes, it's a GUI, but he has this, you call it, how do you call it? It's like words, right? For processing text, or text editor, okay. You call it a text editor. So there's a text editor within the GUI. The text editor is that part of the GUI where you go and type, where you can enter a statement or whatsoever. That's where you code, where you enter your code. It's called a text editor. So you go to the text editor, you enter. So Anaconda comes with that text editor, which is embedded in the GUI. But beside the text editor, which is Spider, you also have Jupyter Notebook. And Jupyter Notebook is really comes with in handy. It comes in handy because with Jupyter Notebook, you just go to the browser. When you open the browser, and any computer has a browser. You just go to your browser, you type your command, and you don't need to run per se. Just press, I think it's Shift Enter, and it will run that particular cell. You see, it is really the simplest way you can learn programming is to use a Jupyter Notebook. Enter a command in a particular cell. You press Shift Enter, and it will run that particular cell and return the results. So it is interactive. You can really see. You don't need to write the entire program before running. You can write a chunk of what you want to do, run that cell, and see the result. If it is wrong, you fix it before you proceed. So it's really, it comes in handy. Please get used to that. And that's what we did, or we are going to do. We did that during the first semester, and that's what we are going to do again today for the Python session. So let me quickly open the chapter 1 for us to see the MATLAB code that we ran last time. I will not open MATLAB because that would be another long process. I did not prepare for MATLAB. I didn't open that. If I try to open to launch MATLAB, it might take some time. But I want us to. I'm doing this just to refresh your mind on what we did, because if I ask you what did we do last time, most of you did not look at that, and you will not be prepared to answer. So that's why I rather want us to look at what we did by looking into the. Okay, let me share this with you. I have a. I hope you will. Okay, yeah, that is it. So this is what we did last time. So this is our x vector. This is our y vector. I explained this. I explained this last time. And this is the linear system. And this is how we constructed our matrix. This is our coefficient matrix. Our coefficient matrix is C, this one. This is our coefficient matrix. So what we have here, we have CA equal to B. So this one, these 3 rows, I mean 1, 2, 3, is for the construction of C, the coefficient matrix. So this is a coefficient matrix. And this last one allows us to solve C A equal to B. This is a coefficient. In fact, this A and this B are vector, and this is the matrix, this one, C. So we have C A equal to B. And for that, we use the backslash, the MATLAB backslash. And once we have A, which is the solution, and you can see that the solution here are the A's, A0, A1, A2, and A1, all those A's are what? The coefficient of our polynomial, right? So once we get the solution, A0, A1, A2, we substitute back into the equation, that one, the polynomial. So that is where, this is where we extract the coefficient from the solution A, right? And now, to obtain the polynomial, this is actually the equation for the polynomial, right? This is where we compute it. This is where we compute the polynomial. Here. Obviously, this polynomial, this is our polynomial. Okay, so this is what we did last time. Okay, now today, what we are going to do, we are going to repeat something similar, but using Python. You will see that in Python, you don't have the backslash, and you need to know what to use in Python. So that's what we are trying to, we are going to do. So let me, okay, now if you read that this result, you will see that this result gives us, the result gives us the coefficient of the polynomial A0, A1, A2. So I'm going to write this coefficient down. And we are going to solve. So I will launch Jupyter Notebook. It will open the browser and we'll go straight to that. Okay, please your patience because it's busy loading. It's busy loading. For us to proceed, Okay. Okay, great. So good. Okay, so Jupyter Notebook is there. Let me. I will share the window with you. So let me just share it. Okay. So this is a browser. Anybody, if Anaconda is installed on your system, you have a browser by default, right? You already have a browser. It can be Internet Explorer. It can be Firefox, Fedora. No, not Fedora. Oh. Anyway, there are so many. Okay, so let me change that title and put what? Least square method. Square. Okay, I'll just leave it like that. Least square. Then I save it. Okay, you can see that the name has changed here. This is the name of our file, which is least square. Now, what I will do here, I will just call the packages that we'll be using, right? The package that we are going to use is NumPy, because NumPy, I would say, import NumPy as NP. This is just an alias. NP stands for NumPy. Instead of typing NumPy each time, I will use NP as an alias, right? Good. Next thing, I will do this. If I want to plot, I will just say matplot. Okay, this is what we call the magic, what is magic number or what? It's just to allow my plots to be embedded within the cells instead of popping as a different window. Remember last time when we ran our MATLAB, when we plotted using the MATLAB function plot, you know that MATLAB function plot would just create a new window that will pop up on the screen. Okay, so, and because of that, you will not be able to see, I cannot share that one, but I can share the plots if I use this %matplotlib is what we call magic. What is magic number or magic something? This is what will allow us to see the plots. Okay, so that is it. I can put a space like that and enter. Right, enter. Okay, now I have a new cell. Now in that new cell, I'm going to define my two vectors, x and y. Right? So these are the for x, x. Okay, let me check from the other file. The values of x, I think it was 1, 2, 3, up to 6. Great. So it was up to 6. So 1, 2, 3, 4, 5, 6. Okay, now I will transform this into an array. I will say np for NumPy array. I convert that because just this is a list. If I don't put array, it will not be an array. This is a list. I convert the list into an array. We did it in the first semester. If you don't know, or if you forgot, please, you can go back to the notes, my Python notes, and you get those information. They are there. Okay, because we'll be using NumPy, so we need our NumPy array. Okay, now the values of y, didn't write the values down. So for that purpose, I need to copy the values and enter. I will need to copy those values. Okay, so the values of y the first is 3.54, the second 4.55, 2.25, 6.50, 8.98, and finally 9.88 transpose. So that is, okay, I will enter those values. So 3.54, 4.55, 2.25, 6.50, 8.98, 9.88. So these are the values. Now, the next thing, because we need to solve our linear system, but let me enter this. Okay, what is happening here? Okay, it's still running, but anyway, let me insert a cell below. Okay, now I will define my C. C equal to if you remember, C is our coefficient metric, and in order for us to define our C, if you recall the way we define C in MATLAB, what we did for C, okay, we took the first entry, we defined using ones, right? And then we entered x in the second column, and then x squared, because we already have our x, so we have all of them. So we can do the same thing here. So we can do the same thing. We can do the same thing. Okay, so in Python, we'll do that differently. Yeah? We'll do that differently. So in Python, we are going to stack. We are going to stack the matrix. I think maybe here I need to transpose this too. I will need to transpose this, but anyway, let us leave it like that for now. So we are, for this one, we are going to use the numpy dot stack. So we are going to do vertical stack. I will explain to you what that is. Vertical stack will allow us to pile the matrix. Stack is like piling the components, stacking them. Okay. If you remember, if you write the coefficient, so we first have to let me look at how we constructed the other one. Okay, so the first column was A, right? First column were the ones. Everything was one, so I will use ones for the first column. The second column will be x, and the third column will be x squared. So that's what I'm going to do. So we say first column are the ones. So we say numpy np dot ones. And that ones will be ones with the length of the vector x. Good. So that's our first column. In the square bracket, because inside here we have, see the way we did with with x, we have a list within, and then we convert that list into an array. So we need also a list inside, and then we'll convert that as a vertical stack, so that it becomes vertical like this That is, 1 will be aligned vertically, that will be the first column, and then X will be the second column, vertically stuck, and then the next one. Okay, so comma, we need a comma here, and then we enter the X component. So that will be X, comma, oh, sorry. And then the third component, one component, first column, second column, and then the other one will be X squared. So for X squared, we say X squared. Good. Now, let me display this to make sure that we have exactly what we want, right? We are going to, I'm going to print this, print, to see if it returns what we want, because we are not practicing witchcraft here. We print and see. Okay, still, no, we need to transpose this, right? We have stuck it, but we need to transpose, because you can see we need to transpose. To transpose, we put dot and capital T for the transpose. Okay, now with this transpose, you will see that it will align it the way we want. So enter, good. You see it's not witchcraft. You see that now? These are the coefficient of A0, everything is 1. So there should be 6. 1, 2, 3, 4, 5, 6. Good. And now for X, you know that X is 1, 2, 3 up to 6, and then X squared. Okay, you can see that this gives us the square of each entry. You see, it's not witchcraft. So what we are doing is correct. Good. So we are confident that we are doing the right thing. It's not witchcraft, guys. You should congratulate yourself. So far, so good. Guys, are we together? I hope I'm not dealing with robots, eh?
Yes, sir.
Are we together?
Yes, kind of.
Great, great, great. So far, so good. Is everything clear to you? Okay, so you don't want to say anything. Okay, now we are going to compute our solution. We are going to compute our solution. Remember. We need the coefficient A0, A1, A0, A1, A2. And for that, we solve this, the linear system, C times the coefficient, that is our capital A, equal to B. B is what? The right-hand side. And what is our B? Do you recall what our B is? B is equal to Y, right? B is Y. Okay, so B is Y. We need that one. We need Y, which is our B. Okay, so let us do that. So I will put the coefficient after. Let me do this. So I have numpy dot, and this is the function, the linear algebra package in numpy. There's a linear algebra package dot the name of the function, list square. Good. Now we write our coefficient matrix X and then comma and then Y. That is our B, right? If you don't want to, we can say R con none. We don't want to condition R con none. Good. Good. Now we are going to retrieve our coefficient. you are going to retrieve the coefficient, right? A0, A1, and so forth. So if you look at the way we write the component, A0 is the constant term, which is our C. We start from that. So we start from A0, A0, let us write it that way, comma, A1, comma, A2. So we want to make sure that our order is correct, because remember that here we have the coefficient of, these are the A0, the constant coefficient A0, and then this one is the coefficient of, these are the coefficient of A1, and these are the coefficient of A2. So we keep that order. But if you write this in a different order, that is, if you start with x squared like as the first column, second and third, you reverse the order here. So this is the correct order. So let us, okay, I will do that and then I will print. Let me do this. We know already the values of the coefficient we are expecting, right? Because I copied from the MATLAB result. Now, after that, I will just print. I will print the result here. Okay, so I will say A0 equal, then I will substitute that result here. Okay, there's an easy way. Okay, let me do this. Yeah? I can use another form of formatting, which is really easy. I put F here for format, and then I put the apostrophe like this. Let's test that. Eh? I've not been using that much, but the good thing with this one is just I just substitute my coefficient here. Just substitute my A0 inside directly. I say that is my A0, comma, A1 equal to, and then I put A1, comma, A2 equal, like this, and then I put A2 inside. That's just a formatting, eh? It's a way to format. Okay, now let's see if this works. If I print that, what do we get? Enter. Good. Okay, now let me check. A0 was 4.1210. 1, 2, ooh, guys, it's not witchcraft. Ha, ha, ha. We have the result. Oh, congratulate yourself. Okay, and A1 is negative 0.9144. 9, okay, good. Because if you round up, it will be 44. Great. A2 is 0.3316. Oh, that is it, guys. Not witchcraft, guys. Ha ha ha. So you see, for those of you who don't have MATLAB, don't go and cry. You cry on your face, you start crying. Oh, mom, give me money. Oh, dad, please, I want the MATLAB license. Please, can you give me money? No, you don't need to cry like that. You just go download your Anaconda package, install, and you have everything for free. You don't need MATLAB license. Everything is there. Free education. Not free because you pay for the module, but extra free information. You see, I could have just said, let me just teach them MATLAB. I don't need to teach them things that are free. And then I confuse you. You go there. I cannot even run any MATLAB. I don't have MATLAB. You cry like a child. You cry like a child. I've been eating mango. I don't have money to buy the MATLAB license. No, you don't need MATLAB license. Free of charge. Mahala. Free. Good. So that is it. So you have everything for the least square. free. You can check your result. When you solve something, you can always check with this one. Okay. Next thing. Okay, now if you want to plot this, what are we going to do? That's a nice question. Okay, because remember, I use this matplotlib. I use this one. So that if we want to plot the, okay, let me first plot this one, the cloud, if you remember. Plotting. Hey guys, free education, guys. You don't pay anything. Oh no, but you pay at least something. But you don't pay. Anyway, it's free. Free education. Okay, now let me go back to this and import. But okay, but maybe I don't need to include it here. Let me come and import it here. Since I already I've run this already. Let me include the matplotlib. Okay, you can see here. Okay, that's not interesting. That important. Let me import matplotlib, right? Import, because we are going to plot, import matplotlib dot pyplot. We are using pyplot. So the alias for that will be plt. If you are accustomed to what we have been doing, you should know that this is we are using pyplot, plt for pyplot. Good. So the first thing we are going to plot the cloud of points, right? For you to see, I'll plot that first. So I will say plt plot, plt dot plot, right? Plot. So I'm going to plot the point x, comma y. Oh, x, comma y, comma. Now we use the O. Oh no. Space O for the circles. I can say for the label, I can put a label there for you to see. Label, I would say the original data. Original data. Original data. That is it for that one. Okay, now for the marker, right? Marker size. Sorry, the marker size. You can take the marker size to be, let's take 10, so that it will be big for anybody to see. Okay, now let me run this first, right? I want to, okay, I will also add the legend, right? Because I already said there. I will leave a space there because I will add plot legend, plt dot the legend, and then show plt, because if I don't put show, I will not be able to see the result. Show. Do I really need that show? Okay, anyway, do I need the show? Since it will be embedded. Okay, let me see. Let me run that. Enter. Okay, it's not witchcraft, guys. I hope you can see the plot. It's not like in MATLAB. You remember that with MATLAB, you couldn't see the plot because it was in a different window, but here it is embedded. And you can see this thanks to what? To this magic combination, this one. You can see. So if you want your plot to be within the cell, you put the percent and then matplotlib. But this matplotlib is not the matplotlib. It's different from what we are doing here for the plotting. So you still need to import matplotlib dot pyplot. For you to use the plot function, you need to import this. So this and that, they are complementary because you need this one for your graph to be embedded, and you need this one to use pyplot. So please, okay, and then this one, plt.legend, is for this legend, original data. You can see that's there. Okay, now you can see we have our points here. 1, 2, 3, 4, 5, 6, our 6 points. So these are the original data. Now we are going to to plot our polynomial, second order polynomial that will fit this data. So that's why we are going to add that here, right? Okay, data fitting, let me comment that and add it here. Now data fit the data. With P2, P2. And we have the coefficient here. They are here, A1, A0, A1, and well, yeah, they are there. So now what do I do? I just, I will copy this. That's to avoid typing too much. I paste it there. I remove what is not important to me. I delete that. I delete this one. So for the label, I would just say fitted polynomial. So second order. Polynomial. That is our label. Now here, I can remove this because it will be a line. But I can put the color. I can say I want the red color, for instance. And this one now, this is where I will write my function, right? Here, I will write the function. I will write the function here. I will write our function, which is our second degree polynomial, don't forget. That one will be our second degree polynomial. Okay. I can use a new x or x fit for that. I can define and use x fit with more points, but let us use this original x and see what we'll get. If it's not good enough, then we can take a finer grid for our x, but let us use it first. So here we'll write our A0 plus A1 times x, right, plus A2 times x squared. So that's our polynomial. Okay, now if you run this, you see that the new line in red will appear. So that's what we have. Guys, it's not witchcraft. I did it in front of you. I didn't just come with something, I just plug it there, say, okay, see, this is the result. No, I did that in front of you. So you cannot go and say that, oh, he went there, he did something, he just came and he pasted that, he said, okay, guys, swallow this, this is the result. No, that's not math. Here we are doing true mathematics. Guys, it's not witchcraft. Now you understand and you know it, you can do it also. Great. I did not hide. I didn't hide anything from you. And Kashopi, are you there? Are you there, Kashopi? Are you not? I hope you are not sleeping.
Sir, I'm here. I'm not sleeping.
That's very good. Do you understand what you have been doing?
Yes.
That is good. I'm happy. That's correct. That's wonderful. That's awesome. So we can continue. So we proceed. Okay, that is it for this. All right. So even if you stop here just for today, yeah, you have learned something because you can go and reproduce it. You don't need MATLAB. No, you don't need to have MATLAB installed on your computer. I know that a lot of you don't have MATLAB. So this is free. If there's something you can, in fact, your take home today is to do this and be sure that you can get that. Yeah, at least learn something and make sure that you always remember that. And also the formatting here, instead of what we used to do, you can see that you can also use this form and substitute the value directly inside and you get the result. So that's also something that you have learned. And the least square function to solve the linear system in Python using the NumPy library is this. This is how you write it. Right. So it's there. You have everything. You have everything. Everything is there. Everything is there. If you can reproduce this on your own and do more problems where you feed the data and get these various results, you should be proud of yourself. Okay, so I think we should stop here for today to allow you time to go and digest. You need to go and digest this. Learn the various, you really need to master Python. Python is really a powerful language. It does almost everything and for free. Right. Great, 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 great. That's wonderful. That's awesome. That's great. That's maravilloso. Okay, so we will stop here. If there's any question, okay, let me give room for questions. We still have 6 minutes. I will give you the floor. If there's anything you want to understand here, ask it now. Because tomorrow, don't say, I don't understand this, I don't understand that. I was not given an opportunity to do this or to do that. Okay, you have the floor. Any question? Any question? Simeon?
No question from my side, sir.
So everything is clear, like crystal. Okay, great. Emmanuel? So far, so good. Any questions? Katuo? You have the floor. Ask your question. Apparently, there's something you want to ask. Frida, or whatever. That is my mom's name. My mom is called Frida. So Fried, yeah, Frida. Aaron Fried. If I split that into two, I have Fried. Fried or Frida. That's my mom first name. Okay, Katuo Fried or Frida, Aaron Fried. No question. Maybe she's not even there. She just came there, she logged on, she disappeared so that we say, oh no, she's present. Maybe if the parent asks, okay, can you give me the proof that you attended the class? Oh yeah, you can go, you will see I was there, log on, you can see my picture. The rest, she disappeared. Nyambe, any question?
No, sir. So far, so good.
Thank you. Abraham, Salomoy, so far so good?
Yes, doctor.
Great. Thank you so much. I think we can stop here. Thank you for your kind attention. God bless you and see you tomorrow. Yeah, tomorrow. See you tomorrow afternoon, 3 p.m. Bye-bye.